Hello, my name is Carl Morrow, and I have chosen to do Norfolk Southern as my company, and the technology I will be talking about is positive train control. Norfolk Southern has been around since 1872, almost 2 centuries. I am currently employed by Norfolk Southern as a general foreman in the locomotive shop in Enola. In the photo is pictured the first locomotive NS bought, which was down in Charlotte, South Carolina, back in 1872. NS currently employs 28,044 people in 22 states with about 35,625 miles of track. NS has always been looking forward to the future with technology and has always been a leader in the technology in the rail industry. You might have heard about Horseshoe Curve that was built in 1854 outside Altoona. This was built for the purpose at the time so locomotives, conventionals, could get over the Allegheny Mountains and open the East Coast to the west for trade. Or maybe you heard in 1963 the largest piece of moving machinery on the planet. Two of them were built and placed in the Lamberts Point coal pier down in Norfolk, Virginia. And still to this day, they are the largest shiploaders of coal. So when in 2008, the Obama administration and Congress passed a law for Rail Safety Act to help prevent train accidents. At this time, it was the most costly federal mandate in U.S. rail history. The only thing is that when this system they wanted to be installed on locomotives didn't exist. It had to be developed and implemented. The technology didn't exist. All this, none would existed. The cost for NS to put all this technology on the locomotive will be $1.8 billion is an estimate right now. It's a rough estimate. In 2015, due to all the Class 1 railroads were not going to be able to meet the mandate and have the system on the locomotives as was directed in 2008, Congress extended the law to 2018 and gave for all equipment to be installed by then, and that all locomotives and the system to be fully operational by 2020. This picture I show here is the system. Actually, these are the main lines of the trackage that NS operates on in the eastern United States. As you can see, most of it is east of the Mississippi. They do dip down into a little bit into New Orleans, a little bit into Kansas City and Chicago. NS mostly is in the east. There are major routes that are out and many smaller routes that aren't indicated on the map. As you could see, there's no major routes you see inside of Pennsylvania really, except towards the bottom, but there are routes that run in the upper parts of Pennsylvania that is small routes. These are the ones indicated are the larger routes. The two big turning points for Class 1 railroads where commerce gets shipped. So if you're shipping something from New York City and you want it to go to LA, it would go across to Chicago and get turned over to another railroad and it continue on, or it would go down to New Orleans and continue on to some of the big West Coast railroads. Class 1 would be BNSF and UP. All the tracks shown will be updated per the law come 2018. All the equipment will be in place and will be fully operational by 2020. This is a large hill to climb to have all this done. to have the technology be non-existent to making it, forming it, bringing it online, testing it, and making sure all the bugs are worked out is a big outcome, and it is being done, and there's been forward progress, but with every bump in the road that they find, they find a way to overcome it between software and hardware. This picture here kind of gives you an overall view of how PTC works. You have onboard systems, wayward systems, and back office servers. All three of these work together to communicate between the track signals, the dispatchers, the back office servers, and the locomotive to let people know where the train actually is sitting at present time. It's a real world scenario. It's real time. It's not delayed. When working correctly, PTC will be that safety device to see something that's not right and stop the train. It should, it does this in different ways. First, if the train is going fast, which is too fast for the track that it's on, or if the condition, it will warn the engineer to control their train. If the engineer fails to obey the warning and dismisses it, the computer will take over and stop the train. It will first slow it safely and then stop the train. Now with PTC, it will let all the other trains it is stopping. It will let all the other trains know it is stopping, either have them slow down or stop. All trains run in blocks. No more than one train can be in a block at a time. And they usually try to have a block in between for stoppage. And depending on how many blocks in between each train is depending on what the track speed they will let them drive at. And hopefully with all this, it will avoid collisions and problems and accidents. The back office server is monitored 24/7 by an operator. This slide shows the servers and the monitors as you see the gentleman watching. In the picture, you'll see the operator watching the screens for any problems. This is real-time data, as I said before, to him through the train and the way stations. The arrow is pointing to the track section being watched by this operator. All the operators will have sections of tracks, and as you can see in the picture, it shows the lines you see in the upper right hand corner are actually tracks. And by indication of colors and everything and symbols, it will tell him what train, by a train symbol, what's in that train, what's there, how many blocks in between the other trains, where they can monitor the speed and the traffic on the tracks. In this slide, you're going to see a locomotive on the track. And you see the signals on the right-hand side. You can see they're yellow. And there's 3 yellows. And depending on what direction the yellows are, they can be yellow, green, or red. And depending if it's showing yellow, that's going to tell the train to slow down. Just kind of like a stoplight. If it's red, they have to stop. They can't go through a red light. Yellow will tell them to slow down to a certain speed. If it's green, they can operate at whatever the track speed is for that area. The arrow on top of the picture shows the antenna array. The antenna array on top of the roof of the locomotive have multiple antennas. They're 2 big large boxes with multiple antennas. The antennas are all from satellite, GPS, digital radio. All this is used to communicate between the locomotive, the way station, and the way station sends it back to the operator at the base station who is observing. And it goes back and forth as communication. It goes both ways. On the And the rest of the gear that you can't see is in different places of the locomotive. On this locomotive, most of the gear is in the nose. There's a rack for computers and items that are in there. They're all wired throughout the cab on a locomotive. In some locomotives, it's in behind the cab in a different compartment. They're all fitted different depending on the class of locomotive and where there was space. Right now, it takes an average of 108 employee hours to install the system on one locomotive. And at the end of all this, in 2018, NS should have 2,900 locomotives equipped. The way systems by the track here is how the communication from the base station to the locomotive goes back and forth. In the photo, you see the way station. The one arrow at the left is pointing to the lights. And that's what I was indicating before. They're kind of like stop lights, but they're lights. There's green, yellow, and red. And the yellows could be in different directions. And that tells him to slow down on his approach. And to have caution. Green, he can open it up and do whatever the track speed is. And red, of course, stop like anywhere else. The one arrow is pointing to the base antenna. And that's the antenna that sends a signal back and receives them. Also, you'll see the one arrow towards the bottom that points to the box that actually controls. The signal comes into the antenna, tells the lights, and that's like the brain. It goes back and forth of what the communication is doing. At the end of all this, in 2018, NS will have installed 3,400 way stations along the routes that I indicated. Okay, then we have training for the engineers. You have all the system, but then you got to have people know how to use it. And this is the simulator that's in McDonough, Georgia. This is for engineers to learn how to properly operate the system. You see the arrows pointing at that screen. The screen the arrow's pointing at is actually the PTC screen. And that will give them indications to follow. The other screens are for the locomotive use, but the one there pointing with the arrow will tell him what he can do. Track speed will tell him. It'll tell him cautions, blocks. It'll give him his GPS location and some other things. NS also has some mobile simulators that are up and running. So if they can't get people to McDonough, they got some mobile simulators. They got them out in the field training people. When it's all said and done, by 2018, NS will have 21,000 employees trained for PTS. Now, why do we have PTS? PTS came about because too many accidents. And in this case here, PTS, this is the accident that happened outside of Philadelphia, where the train was taking the curve way too fast. He was over 100 miles an hour. And was not the speed for that trackage. This is where PTC could have helped. It would have made the engineer know that he had to slow down, and if he didn't take appropriate action, it would have slowed the train down and stopped it and took it out of his control or her control. This is where I believe the technology really can help out in saving lives and in property damage. The PTC will probably take some jobs out on the economic side, but I believe that with the technology, it will actually add jobs. You'll lose jobs maybe on the crew for people operating the train, but because of all the maintenance and installation and everything else that goes along with the system, I think you will add jobs in the long run. Well, that is my slideshow. Hope you appreciate it and liked it, and thank you, and have a good night.